Mm. Okay, electro-optics. Photoconductivity, photovoltaic devices, sensors, encoders, and optical isolators. So the photovoltaic effect is when light hits a in material as part of a p-n junction, it can excite enough or impart enough energy to create free electrons that can move, just like if you apply a voltage to cause that to happen, or uh, most any other kind of energy, you can actually do it from applying enough heat, which is the way old vacuum tubes worked. You heated the cathode up enough for it to create an electron cloud around it of free electrons, and then the voltage between the plate and the cathode would cause those electrons to actually travel across the vacuum of the tube. So here, the electrons in that end material are absorbing that light energy, getting enough energy to get above the Fermi level so that they conduct. Oh, thought there was another one. So what is the photovoltaic effect?
Oh, electricity.
Conversion of light to electrical energy. What absorbs energy from light falling on a photovoltaic cell? Right. The good old electrons. Okay, the most common type of cell is made from silicon crystals. The approximate open circuit voltage is about a half a volt. I'm not sure what it is when it's under load, but they figure half a volt when it has full sunshine, fully illuminated. Um, the efficiency is a relative fraction of the light converted. It's my understanding it's around 20%, assuming that the array is perpendicular to the light source and it's clean and all that good stuff, and that you're like at the equator. Um, they've made great increases in the efficiency, but still, I think it's down in the 20% range, which isn't all that bad. I mean, a gasoline engine is 20%, and they've been working on those for a long time.
You need to let us continue to work on them to improve your efficiency. At least the next 100 years. Yeah.
What's the most common type of photovoltaic cell used for electrical power generation? Silicon. Silicon's in everything, even in people, right?
Some people. Yeah.
Some people. What's the approximate open circuit voltage produced by a fully illuminated silicon voltaic cell? Whatever that cell is. Half a volt. So what's the efficiency of a photovoltaic cell?
Okay.
Right. Yeah, they don't commit to a number because nobody exactly knows. It depends on a lot of factors. Photoconductivity is a similar effect, but instead of producing a voltage, it changes the conductivity of the material, or basic resistance of it. So you can use it as some sort of a sensor to detect light or absence of light. And again, semiconductor crystals are most commonly used to make them. So what happens to the conductivity of photoconductive material when light shines on it?
Increases.
Right, it increases. Which material is commonly used to create them? Another device, optical device, is called an opto-isolator, where you pair up normally an LED with a phototransistor or a photodiode, so that the current flowing through the LED causes it to emit light, which shines on the phototransistor and causes it to conduct. If it was a photodiode, it would do a similar thing. You could even, I don't think I've seen them, but there's no reason why you couldn't do it with an LED and a photoconductor to have a variable resistance. The basic thing is it electrically isolates the two circuits. The current coming in through the LED is totally independent of whatever current is flowing through the transistor or diode on the output. So you can operate hundreds of volts on the output with 3 or 5 volts on the input. And the only real limitation is the physical gap in the material, whatever that insulation resistance, I guess you'd say, before voltage, can actually get high enough to jump over between the two. Normally,
It's physical distance.
physical distance, right? Although it's not much. I mean, they're separated with a little air or vacuum gap in that package. Most of the solid state relays, AC type relays, basically have an opto isolator in them, because you control them for 5 volts or 12 volts, and they'll normally do 120 or 240 volt AC at some very high currents.
Isn't it also quicker switching?
Oh yeah, faster than a relay. It's really an electronic relay. And those are isolated because the coil in the relay is independent of the contacts for the relay. So it's just a solid state version of a mechanical relay. Typical circuits for one with the photodiode and one with the opto transistor. Sometimes they'll bring a base connection out for special purposes, like maybe you can bias it differently. I'm not sure. Normally, it's just the controlling the current between the collector and the emitter. So what's the most common configuration of an isolator or optocoupler? I think HP calls them optocouplers. Why are they often used in conjunction with solid state circuits switching 120 volt AC? Let's see.
I think isolation is
Right. Oh, okay. And solid state relays we just really talked about. It acts just like a mechanical relay. They're built, usually they have a opto isolator in them to do the isolation function. So what is the solid state relay?
That would be good. Probably.
Okay, optical sensors. Most common one now, and most modern radios, for instance, you no longer have the old potentiometers where you're varying a resistor. It'll be an optical encoder, and you're doing steps, and you're digitally controlling the tuning or the volume.
The motion of the dial is translated into encoding. It's
Right.
and producing.
And you're just counting up, counting down. And it's very easy to do when you got a microprocessor inside. So it's basically you've got some kind of light source, usually an LED, a detector, and a wheel of some sort, interrupter that has holes in it to let the light through in specific patterns. And normally you'll have three outputs. You'll have an A and a B, because so you've got a quadrature output, like I and Q. It's the same kind of thing, so you can tell direction. And then you'll have a Z output, which is just one spot, so you can tell when you've done a complete turn. It's like the home position. So every time you cross that, you get a pulse which says I'm at 0. So you know how many turns you've done, where the other pulses are telling you what fraction of a turn you've done. Okay, so that's how you tell direction because of the A and B channel being in quadrature. Normally used, like I said, for most radio controls nowadays. Anything that you rotate is probably an encoder. There's kind of a simplified version of one. And those code disks are usually laser generated. So they actually have light and dark spots. It's like a clear plastic wheel, and they almost like a negative for film. So they can do very high resolution. You can have it. I've seen them with 1,000 points. So what describes an optical shaft encoder?
Okay.
They also use them on control systems, on servo motors and stepper motors to detect position, control, and close the loop with it. All right, that was a quick one. Any questions on optical stuff? Those were easy.
Mm-hmm.
How about seeing the end, I guess?
I worked on CTLs. I was the master of the control head bench at Something's Aerospace for 10 years. So, well, not 10 years, 7 years. But the last 12 years, I've been working on gyroscopes. Well, the gyroscopic can, it has a gyro in it and the optical switch and everything. He's got a disc on it. It's got 720 little windows on it. And every time there's a change of state, when that window passes by that optical switch, it changes 1/4 of 1 degree. So make it out over here. Yeah. And then I was telling my manager, I said, oh, you should see this. It's really cool the way they describe this optical switch and how it works and everything. And he said, where did you see all that? And I told him, I said, well, it's in New Hampshire.